Good afternoon, everyone, and welcome to our special industry webinar on potato mop-top virus. My name is Shakira Johnson. I'm the Farm Biosecurity Program Coordinator at AUSVEG, and I'll be hosting this webinar today. We've gathered some leading experts to provide some insights on their experience or their knowledge on potato mop-top virus, from the official government response to on-farm practices and the science behind the virus and the vector. Our goal is to equip you with the knowledge needed to proactively manage this challenge and implement on-farm practices and ensure the ongoing health of our potato crops.
Thanks, Shakira. Could I check that everyone can see? Fabulous. Thank you so much. Thank you so much. So thank you for having us here today. I'm just going to run very briefly through the potato mop-top virus detection and current and future activities that are underway or going to be underway. So first of all, I just wanted to set a little bit of context around the operations here, both in Tassie and also from a national perspective. I'm not going to go into a whole heap of detail, but I think it's important to recognise that here in Tassie, when we have a biosecurity emergency response, we operate under our state special emergency management plan. And within that, Biosecurity Tasmania is identified as the lead agency for biosecurity emergencies. And so when I talk later in this presentation around an incident management team, so an IMT, that structure is actually guided by the incident management structure that follows AIMS. So you can see it written out there in full. And AIMS is that structure is also utilised for things like fire and flood. So it allows for interoperability and also, consistency in practices across all hazards, including biosecurity. Now, overlaying our response at the state level, this as a exotic pest to Australia, having been detected in Tasmania, the emergency plant pest response deed is also applicable. Now, the state of Tasmania is a signatory to the National Emergency Plant Pest Response Deed, as is AUSVEG, representing potatoes for the purposes of the deed. So under that arrangement, under that agreement, that guides national decision making and potentially the cost sharing for any responses for EPPs, such as potato mop-top virus, if it's agreed nationally that the pest is feasible to eradicate. So just a really brief overview of how we got to where we are now. So we had an industry member identify some concerning symptoms in a potato that had originated from a property in the northwest of Tasmania. So that sample was submitted to Biosecurity Tasmania's plant diagnostic labs mid-July. And a few days later, we had an initial positive PMTV outcome. So PMTV, it's just the abbreviation for mop-top virus. So at that point, we put together a structure of an incident management team. We commenced industry engagement, tracing. So when I say tracing, it's seeking to understand trace forwards as well as trace backs. So what has left the property, what has come onto the property. Further investigations and sampling were initiated. So the site was also contained. Here in Tasmania, we operate under the Biosecurity Act 2019. And so the site was contained and subject to a biosecurity direction under that act. And as the deed, the emergency plant pest response deed guides us to do, we actually undertook second confirmation by a second independent laboratory. And that was provided back to us on the 30th of July, confirming that, yes, we are actually dealing with potato mop-top virus. So what we're in now is what we refer to as the alert and investigation phase. It is also sometimes referred to as the incident definition phase, but for this context, I'm calling it the alert and investigation phase. So what's our current focus? During this phase, what we're trying to do is determine the geographical distribution and assess feasibility of eradication. So that's one of our primary drivers at the moment, to understand the potential distribution here in Tasmania. We are also cognizant of the impact this has on our industry, and so one of our key objectives is also to minimise impact on affected businesses and industry. And through any response, not just this one. It's really important and a key objective to ensure the well-being of our response personnel and also our industry stakeholders. So how are we going to achieve this? At this point in time, our focus is on minimising spread from known infected sites, and we're utilising the legislative tools that we have, as well as direct engagement with our impacted owners. We're also doing strategic sampling and testing of available material across Tasmania. So we're drawing on the insights, knowledge, and connections through our industry liaison officers and industry representative organisations to work with them to access materials so that we can actually do some more general surveillance of material that's currently available here in Tasmania with a priority focus on seed that's in storage. So as I highlighted, we're actually working really closely with industry throughout this response and also subject matter experts. So I'm really happy to see so many of them here today online. And that's so that we can do informed response activities and also facilitate information sharing. And critically throughout, we're looking to mitigate or minimise any of our work, health and safety and wellbeing risks. So what's the current situation? As you may have heard through the media, under our objective of determining that geographical or potential geographical distribution, we've identified 6 what we refer to as infected premises. So in total, 6 identified. So 4 of those have been identified through tracing, which means we've managed to identify a linkage between those sites. And 2 infected premises or IPs have been identified through seed testing. So at this point in time, the sites the 6 infected sites are in the northwest, and you would have heard also in the media without a doubt that one of the sites is a small research plot in the south. So that research plot was actually identified through sampling of potatoes present. Now, as I'm sure we have quite an informed audience on this webinar today, I probably don't need to explain what volunteer means in this respect, but I will, in case there is people online that are unsure of that term. It means essentially, and it's used across agriculture, it's essentially potatoes that have potentially been left over from a prior harvest and are therefore in the ground and will re-sprout and regrow. And they're called volunteers. You also hear that term in wheat growing areas about volunteer wheat on the side of the road. So as indicated earlier, all the sites are subject to movement restrictions, and that's to mitigate and minimise potential spread. So these are biosecurity directions under the Act. We haven't identified a potential origin as yet, so trace forward, trace back operations are ongoing. Now, the planting history, the tracing information to date would suggest that the virus may have been present for at least 2 years. The testing of the seed that I referred to earlier, that more broader general survey, given also how close we are to planting season here in Tasmania, that's occurring in collaboration with Tas Seeds. Now, a fundamental part of any response, and this one's no different, is that real strong stakeholder engagement and information sharing. So the key industry representatives that we're working through are Potatoes Tasmania, Tas Farmers, AUSVEG as the national representative for this incident, Tas Seeds, and also engagement through the processing companies that we have here in Tasmania. And we have 2 industry liaison officers working with the incident management team, and that's Potatoes from Potatoes Tasmania and Tas Seeds. And I would like to highlight the workforce that here in Biosecurity Tasmania, but NRE, so the Department of Natural Resources and Environment Tasmania more broadly, we have been scaling up the incident management team. We're operating virtually. We're at a few different sites here in Tasmania, and there's approximately 25 people working on the response at this point in time. So we have established an interoperability. That means it's not just Biosecurity Tasmania that is coming in and supporting activities in this response. We're also drawing across the broader department of NRE Tas. And here we have the plant diagnostic services. And what we're also doing is through our animal health laboratory, which is present up in Launceston, we're supporting them to actually scale up so that they can do some of the plant diagnostics also for us. I'm really happy to report we haven't had any WHS or wellbeing issues reported, which is such an important part of the response too. And we're also looking at identifying and communicating those available support sources to industry and impacted owners. So where are we heading? So we're week 6, if my maths is correct. And so national considerations of the incident through to national arrangements, that deed that I spoke about earlier, those will be occurring soon. We continue to do the trace forward and trace back operations. Testing of seed, we've got a lot of seed lines to get through in collaboration with industry. Critically, industry and public information activities remain core to the response, and we'll continue to do those. And we're listening and hearing those questions that you're asking. And we have frequently asked questions and fact sheets online and incident updates. So please tap into those resources. And noting that, and you might hear a little bit later today from a number of the other speakers, you know, we're dealing with a pathogen, a virus that is challenging to eradicate. So though we haven't made any decisions around that as yet from either a national or a state perspective, we are also considering, well, what would living with the virus look like for Tasmania? You know, that's quite an important element. So we're doing 2 lines of thinking there too. Yeah, thanks, Shakira. I'll leave it at that.
Thanks, Susanna. And next up, we have Doug Clark from Tas Seeds to give us that industry perspective in terms of Tasmanian seed potato certification. So Doug, if you'd like to just have a few words from that industry perspective.
Yeah, no worries at all. So what I might do, I might just start off with testing if I could, because that's a major part of what we're doing currently. So within Tas Seed, we have 230 lines of seed between G2, G3, G4 and G5, of which we're currently testing. We've also got 127 lines of G1 seed, so very early generation seed. Traditionally, through our certified seed scheme, we tuber test 400 tubers out of our G2 lines traditionally, and then when we move seed to the mainland, we also test that seed as it goes. So that Dickia range of pectos virus, of which mop-top has not been one of them, which it is now. So we moved some seed to the mainland through the course of this season, of which we tested, I don't know, there must have been half a dozen lines that we tested before that movement, and we were able to retest that directly for mop-top, and they came back negative. We had some lines that left that we didn't have any seed left over, of which AuSPICA has been very kind to be able to offer assistance in testing those, of which 5 samples have been submitted to Intertech so far, and they have come back negative as well. So it's early days, but yeah, no hits as yet. So we'll see how we go. So we've been full swing the last 3 days, of which we've been able to generate 63 samples this week and sent away to Intertech, which are the body in Adelaide that do our testing for us. So that's approximately 25,200 tubers in the last 3 days. So testing will continue next week and then early into the week after, and we're aiming to have all the results back prior to September 15, so then we can come together as an industry and work out what that looks like, if we've had lots of hits or we've had not many, and just what it looked like in the future going forward. So just I'd like to recognise the Cool Stores process, involvement in this. So when we go to Cool Store to get these samples out of Cool Store, it takes a lot of time for the Cool Store operators and forkies to go into the individual cool rooms and get those, get the product out for us, so we can actually take those samples. So I can't thank them enough through this process. Like, they have been integral to this, and yeah, all we can do is say thanks. So what else? Look, the main thing for me is around soil movement and farm biosecurity plans going forward. That's really something growers can do in the next 3 weeks while we're sort of in a void of not a great deal of information coming out or being available whilst this testing happens. They can actually work on their farm hygiene plans. And when they go out to the paddocks to spray paddocks off ready for the next crop, because there's a lot of crop that has not gone in yet, feel good when you kill a volunteer potato. Like, just genuinely feel good on the inside. It's less of a disease risk going forward, not only for mop-top, but a whole wide range of pest and disease that volunteers or groundkeepers, whatever you'd like to call them, yeah, feel good. Happy to field questions at the end.
Thanks, Doug. Now we move across the ditch to Ian Kirkwood from Potatoes New Zealand. We're very lucky to have Ian join us this evening to share his experience and insights from the potato mop-top virus experience in New Zealand. Thanks, Ian.
Thanks, Shakira. Yeah, I was the technical lead on the response when we detected mop-top virus for the first time in New Zealand. It was my second day on the job with Potatoes New Zealand, so it was a bit of a baptism of fire. So I'm just going to run briefly through a summary of our response and where we currently sit with mop-top virus. So the virus was first detected at a processing plant in the South Island back in September 2018. It was unfortunately detected in a chipstock line out of store, so it was very difficult to trace exactly which paddock it originated from. And similar to the situation by the sound of things in Tasmania, we ended up finding about 6 different suspected infected properties at the time. So the virus was very quickly confirmed by the government diagnostic laboratory, and we swung then immediately into a response. Now, it's slightly different to the Tasmanian situation. In New Zealand, our response is now a joint response between the Ministry of Primary Industries and the appropriate product group, which in this case was Potatoes New Zealand. Now, this was the first response that was ever managed under this new structure, and it did have a few teething problems, I must admit, but I think it worked generally fairly well. So the decisions made by the response team were joint decisions, not decisions entirely by Biosecurity New Zealand. So the first action they took was with the process plant was to insist that the factory waste was disposed of at a deep burial site. Now, this was a very expensive operation for the company involved. The deep burial site was away down in the south of the South Island, and the transport costs were considerable. And as probably everyone knows, the waste from a French fry factory is quite considerable. With hindsight, which is a great thing, it was probably not necessary. But at the time, we didn't know how widespread the virus was throughout New Zealand. So at the time, it was probably a sensible precaution. Responses in New Zealand have 3 distinct phases. The first phase is eradication. We try and determine whether we can eradicate the virus or the pest. The next phase, if we decide we can't eradicate, is containment, to try and restrict the area in which the virus has spread. If that can't be achieved, we then move to a management phase where we develop a long-term management plan to try and minimize the impact of the virus on the industry. So the second action by the panel was to set up an international panel of experts. Obviously, we had relatively little experience with the disease, although one of the experts actually was a Kiwi. So we set up an international panel, and they advised us on how we should respond to the virus. They very quickly came to the conclusion that eradication wasn't possible. Once it's in the Spongospora, in the powdery scab, and in the soil, it's almost impossible to eradicate. So we very quickly moved from eradication to containment, or looking at containment. Now, in order to be able to determine whether you can contain an outbreak, you need to understand where it is. So our first response really was to do a major survey throughout New Zealand. We focused initially on seed, as by the sound of things you have done in Tasmania. We were a little later in detecting, later in the year in detecting the virus, so we had very little time to test seed lines. We tested what we could, and similarly, we found no infection in any of the seed lines that we tested. The initial testing of the sites, the suspected infected properties, took place in two ways, very similar to Tasmania by the sound of things. We looked at volunteer plants in the sites, and we also did some soil testing, and I'll come back to the soil testing protocol that we used a little later. So the rest of the survey focused on the growing crop, and as I mentioned before, it's 200 different sites we tested. Now the results from those indicated that the virus was already quite widespread throughout New Zealand. We picked it up in the north of the North Island right down to the south of the South Island. However, there was a clear concentration of the virus around the Canterbury area, and you could almost tell from looking at the map sort of concentric circles going out from where the virus probably originated. We did detect mop-top in one seed line during that survey, sorry. That was removed from the seed scheme and destroyed, and the grower was compensated for that seed line. So very quickly after the survey, we determined two things. One, that containment really wasn't going to be possible because it was already widespread throughout the country. And second, that it probably had been in New Zealand for a number of years before it was first picked up, which again sounds very similar to the Tasmanian situation. So we moved to the management phase and started to develop a long-term management plan. Now, the only really effective way of managing mop-top is in effect by managing the vector. And I think everyone knows how difficult powdery scab is to manage. It's an extremely difficult pathogen to manage. The International Panel of Experts also recommended that we started to screen cultivars for cultivar resistance to mop-top. Now, quite a bit of this work had already been carried out in the States, but many of the varieties, in fact, the majority of the varieties that they had already tested weren't grown in New Zealand, and in fact, they won't be grown in Tasmania either. The panel decided to put this one on hold at this stage. They decided that they needed to understand the impact the virus was having on the industry before they went to the expense of screening cultivars. Plus, there was the fact that changing cultivars in a potato system is not something you tend to do overnight. It tends to be rather a long process. So they put that cultivar resistance screening on hold. So currently, the only way that we monitor mop-top in New Zealand is through reports from the processors. Every load that goes into the process factory, a sample is taken and the tubers are cut open looking for internal defects. Now, any occurrence of mop-top in those samples are reported to Potatoes New Zealand. At the same time, and again this was happening by the sound of things in Tasmania, we had a trace forward and a trace back to try and determine where the virus was spreading to and where it originated in the country. Given the fact that it had been in the country for a number of years, they were unable to determine how it came in. Many theories were put forward as to how it entered into the country, but none of these were ever proven. The leading theory, which I hesitated to mention, but I will mention, was that it entered on peat coming into the country. Many of the growers, particularly in the Canterbury area, use compost as a supplement in their fields, and a lot of that compost has peat part of it. It comes from the mushroom growing facility in Christchurch, and it's possible that the peat contained mop-top virus. Now, there have been reports of powdery scab in peat. So it's possible that it did come in on peat, but that was never proven. We did a lot of testing on peat, and we were unable to find either Spongospora or mop-top virus. So just very briefly, what we were testing, during the season we were testing roots. Now, Spongospora infects the roots first of all, and we were told by the panel that this was probably the most likely place that we would pick up mop-top virus. So the vast majority of samples that we tested were roots from the growing crop. But as I mentioned, we're also testing soil from various sites. Now, we tested this using bait plant testing. We planted tomato seedlings in the soil, grew them on for a given period, and then tested the tomato roots. There have also been reports out of Scotland that they're testing leaves for mop-top virus. Now, we were told or recommended by our expert panel that that can be a little bit unreliable, and it's not something that we're currently doing. In New Zealand, all our virus screening is currently done by ELISA. Now, you can't ELISA test effectively, ELISA test for mop-top virus. Also worth mentioning was that we haven't actually seen any foliar symptoms of mop-top. Mop-top doesn't express symptoms in the first generation. So in other words, if the plant picks it up from the soil, it doesn't show symptoms. It does show symptoms in the second year. If the seed tuber is infected, it does express foliar symptoms in some varieties. We've never been able to pick up foliar symptoms in any of the crops. Part of the reason for that is the foliar symptoms are very similar to alfalfa mosaic virus, calico, and we may be mistaking some of these symptoms for calico. It is possible. So the current situation in New Zealand is that the process companies aren't seeing any significant losses. There is no significant problems with processing the potatoes. And they don't believe that mop-top is causing a significant yield loss in the field. It is, however, extremely difficult to distinguish yield loss from the Spongospora, from the powdery scab, from that of the mop-top virus. So they don't believe it's causing any significant issues right now. But we have been warned that mop-top virus is often described as a sleeper disease. It can fly under the radar for many years, and all of a sudden it will start to flare up and cause some significant issues, and that is the case in a number of countries around the world. We have been investigating whether there's value in carrying out another survey. Surveys are very expensive, and we are a grower organisation. We've well and truly moved out of response, so we don't get any government help to carry out a survey anymore. And to be honest, our growers are saying to us it's not our leading disease in New Zealand, and therefore there's no value in doing another survey. So roughly speaking, that's where we are in New Zealand right now. We don't see it as a major problem. We have been living with it for probably up to 10 years, and right now it's not causing any major issues in New Zealand. And let's hope that's the case also for Tasmania. So that's all I've got. Back to Shakira.
Thanks, Ian. Thank you so much for your insights and attending on a Friday evening. Really appreciate it. Now we'll move over to Nigel Crump, who has a lot of experience in the research behind potato mop-top virus and collaborating with people overseas, and something that's really been a really great demonstration of preparedness for the industry. So Nigel, take it away and teach us about the science of the virus. Thanks.
So you can hear me, yeah? I hope you can hear me.
We can hear you.
Yep. All right. Beautiful. All right. So as Shakira said, I'm just going to give a bit of a run through about mop-top, a bit about science, and a little bit about certification. Before I do, just a bit of background for AuSPICA. Since about 22, we did visual identification of all crops, and this year that's about 2,300 hectares. So all our inspectors have been trained, and I'll talk about some of that training in a minute. But we also, since this season, all exported certified seed potatoes. So those are exported to a foreign country. That's about 1,200 tonnes, have all been sampled for 400 tuber tests and PCR tested, and all were negative. We also threw in there for export loads, we did a subsample and it was cut for internal defects. So we didn't see any of the symptoms of mop-top and a number of other defects. The reason why we did this was to provide evidence and support export trade, but it also was a way of us being prepared. Part of that was Steve Johnson, our visiting scientist, came across and did training with all our inspectors. This is one of his training videos that talks about symptoms and how to identify it in the field. And the inspectors have to undergo an assessment so they know what the symptoms are like and how they go about sampling. So that's a background in what we had done in preparation, thinking that we'd never ever use the methodologies that we've done. But I suppose just jumping back, what is potato mop-top? You've heard everyone speak about it. This is a virus that is transmitted by the powdery scab organism, Spongospora. It causes yield loss and tuber defects called spraying, which I'll show you photos soon. The soil-borne, it's long-lasting in the soil. So once it's introduced, it really cannot be eradicated. It's in that powdery scab population. We all know how hard it is to control powdery scab. One good thing about this disease, if there is a good thing, in the absence of the vector, so in the absence of Spongospora, the virus will self-eliminate because it's got a relatively low rate of transmission of the virus within the plant from seed to daughters. So we can plant an infected tuber, but only like something like 30 or 40% may be infected. In fact, a study in the UK actually showed that the most efficient transmission was around 49%, where the least was about 23%. So over multiple generations, without powdery scab, without reinfection, the virus can self-eliminate. How is it spread? Infected seed potatoes. That's the main pathway. But it's also spread through infected Spongospora. So anywhere where we're spreading soil, machinery, footwear, and somewhere water movement as well, there can be minor movement of powdery scab. Another big risk is shed dust. And work that was done in Victoria here many years ago, Adolphe de Boer and others, and Stuart Weil in the UK, showed that shed dust was a major risk or potential risk pathway for spreading powdery scab. And this is just dust in the field, in the shed. Drive over it with the forklift and get a cloud of dust, and that coats planting material with inoculum. Otherwise, it's not airborne. The spread of mop-top and the spread of powdery scab is really not airborne. It's a soil-borne issue. I'm just going to go through all the text, and then I'm going to go into some pictures to show everyone, because that's what everyone wants to see. But Ian touched on this. Often there's no visible leaf symptoms. It's really only the seed-borne mop-top that's more likely to show symptoms, and temperature can influence that as well. So generally, in cooler growing regions, symptom expression is not as expressed as warmer production areas. But you can have the disease without the symptoms. The tuber defects are brown arcs or streaks or rings, and I'll show those in a minute. It's known as spraying, but the defects just lower quality and marketability of the potatoes. So as I said, we were lucky to have Steve Johnson, who is the first reporter of this disease in the US. He was a visiting scientist here and has been here for a number of years. This is the typical symptoms you see if you do see it. It's called chevrons in the leaves. You can see they're sort of angular in nature. I don't know if you can see my mouse moving or not, but these angular points within the leaves are classical symptoms of potato mop-top. Ian mentioned it before as well. It can be easily confused with calico or alpha mosaic virus, which we do have in Australia. Just showing some more symptoms. This is again typical sort of symptoms. The chlorotic patches within the leaves. These are some of Steve's photos from the US. And again, we can see from Scotland images of it in the foliage. But again, that is rare. In the tuber, and this is an app, you may actually want to take a screenshot of this, but look at that QR code and it'll take you to a United Nations seed potato defects and disorders guide that we've actually developed online, and it's got a lot of images of mop-top and other potato pests. But this is just showing a typical mop-top lesion on the outside of the tuber, but more telltale is on the inside of the tuber, this arcing with inside that tuber flesh. In terms of incidents, there's some work. Fiona Davey, a colleague who now runs the seed certification program in Scotland, she did some research on this and showed that the level of infection by mop-top is relatively related to the amount of powdery scab infection. So as mentioned before, any attempt to reduce powdery scab is a way of mitigating mop-top. Again, just a typical, more classical mop-top. This is one of Steve's images again, just showing mop-top in that flesh material. If we look at the amount of spraying or that defect in the tuber, this is again some work by Triona, and this is actually showing that the level of tubers infected by mop-top. There's a relationship between the degree of spraying in the tubers. So we can see here, the more the infection, the more the symptomology development in the tubers. Ian mentioned this as well, that, you know, the material can make its way through processing plants, and here we can see French fries or chips, depending on which part of the world you're from, showing mop-top symptoms in the chip. Basically, then the summary: infected seeds are major pathway of spread. So the management strategies use seed with a known status, avoid fields with known mop-top. Ian mentioned about some of the testing and that sort of stuff for baiting, which we don't have available as yet in Australia, but there is work underway to get that. And in summary, really, prevention is better than cure with mop-top. And I'll leave it there.
Thanks, Nigel. And now we will move on to Callum Wilson. Callum Wilson is a plant pathologist who has done quite a lot of work in powdery scab. I know I was first introduced to powdery scab from Callum's research back in 2018 when I first started at AUSVEG, and he's done some really great work there. So we'll now hear from Callum on the vector of potato mop-top virus. Thanks, Callum.
Thanks, Shakira. Yeah, so mop-top and powdery scab, and let's make that work. Yeah. So yes, powdery scab, as has been stated, as Nigel mentioned, the powdery scab organism is the specific vector. So it's the only organism that will spread it around. It doesn't spread around with insects or anything like that. Powdery scab is unfortunately prevalent globally, and it's quite prevalent in Australia too. It clearly likes cooler and wetter conditions. It's an organism it's an aquatic organism that likes soil moisture, but is quite prevalent throughout Australia as well. One of the real difficulties with this pathogen, and why it's become a headache for a lot of people, is that it produces these really robust resting spores. So if you look at those images down the bottom, you've got root galls, which growers may see. You've got tuber lesions, which you hopefully don't see too many of, but you might see. In both of those, you get these things on the right, which are small microscopic resting spores. And these resting spores can be released into the soil, and once they're in the soil, they can persist for a considerable amount of time, generally, longer than a typical rotation, certainly. They can remain dormant in the soil and then become a problem next time you plant potatoes. In terms of how the virus interacts with the vector, so the powdery scab actually acquires the vector from an infected plant. So obviously powdery scab is a pathogen, the virus is a pathogen. So how the powdery scab becomes what we call virulliferous, so in other words carrying a virus, is that it'll come in contact with a virus-infected plant, and during that infection process will acquire or capture the virus. The virus is internalized within the powdery scab organism, and where are we at? Yeah. And that's how it becomes associated. Obviously, these resting spores, they form, as I said, in the roots or in the tubers. At this stage, they've captured the virus, and of course, when they're released into the soil, they then hold the virus for that same extended period of time, that same dormancy period that the powdery scab pathogen has. So that makes this virus a particularly difficult one to manage, because it can obviously reside outside of a plant host for an extended period of time. Transmission is kind of the opposite. So you've got your virulifera's, you've got your virus-carrying powdery scab organism in the soil. It will germinate, it will move to the roots of a potato plant, and it will insist on those or bind to the surface of the root hairs of that potato. And when it does that, it kind of injects its contents into the plant, and in doing so, transfer the virus into the plant. Now, while powdery scab kind of stays to the roots, the virus has the capacity to move beyond that, to start replicating in the plant and move. It doesn't move, it will move systemically, but not terribly efficiently. And that was sort of alluded to, again, when Nigel was talking about an infected plant won't necessarily produce 100% of infected tubers because the distribution of the virus can be a little bit erratic. Similarly, I think there was comments in the chats about leaf detection. Again, it will probably be variety specific, but it can move into the foliage. But it might also be that the tissue you test is negative because it's erratic in its distribution. So the roots are where it's most commonly detected. Symptom expression appears to be fairly rare. And again, that's been alluded to. And that of course makes it, again, difficult to manage from a roguing perspective or otherwise, because we may have infected plants and we really don't know. And that's similar with powdery scab as well. From a foliar perspective, we won't necessarily know we have powdery scab affected plants until we see lesions on the roots, those galls on the roots, or lesions on the tubers. So again, managing, as was pointed out, mop-top spreads and survives and spreads in seed tubers and in soil associated with the powdery scab vector. And again, as was pointed out by Ian, that management approaches really are aimed at that. Well, Ian and Nigel were aimed at seed health and limiting the spread of powdery scab inoculum and root infection. So if we look at powdery scab itself, what are the key drivers of that disease? Given if we can stop that, we can help slow or stop the spread of mop-top. Easier said than done in lots of ways, but really the potato itself. So they do vary in susceptibility to powdery scab, and obviously there are more resistant or less resistant varieties. So a more resistant variety is likely to be more difficult to infect with powdery scab, and therefore possibly less likely to be transmitted mop-top to it. Although it really doesn't, it really only takes, I guess, in theory, at least one infection for that to happen. Plant stress, not only variety, but how stressed or how healthy the plant is will also affect how susceptible it is to powdery scab infection. So generally, healthier, more robust plants have more tolerance or more resistance than ones that are stressed. The inoculum sources are critical. Obviously, powdery scab will be carried on or can be carried on seed tubers, particularly if they're not certified. So if you're using tubers that have lesions on them, clearly that will carry powdery scab. But probably the most important source of powdery scab is the soil. And indeed, there's lots of work to show that soil inoculum is the best predictor of likelihood of disease in the crop. So that the amount of inoculum you've got in the soil will determine your disease risk. The soil environment is also really critical. As I mentioned before, this is a water-loving or aquatic organism. Soil moisture is critical. It doesn't need to be waterlogged, but it needs sufficient moisture. It likes cooler temperatures, although root infection occurs a little warmer average temperature than tuber infection, but it's still a cooler environment disease. Saying that, there's massive outbreaks of powdery scab in the Middle East, where irrigation water provides the moisture and I guess cools the soil sufficiently to allow infection to occur. So temperature management is obviously important, is obviously difficult. And soil health is important again. So structural, chemical, biological soil health, and that relates to plant stress. If you've got a stressed plant, it's more susceptible, but also poorly structured soils will accumulate, will have poorer drainage, will accumulate greater soil moisture. You'll have reduced biological activity, and I guess in the rotation at least, those biological antagonists have the capacity to start to break down that soil inoculum if we've got a very active environment to do so. Look, I don't think we need to cover this because Nigel's covered this already. As I said, seed potatoes can be infected. There may be no visible symptoms of infection, and certified seed should be used. Ideally, seed free from obvious powdery scab inoculum. From a soil perspective, anything that minimises soil movement will help reduce spread. So we're really talking about good farm hygiene practices. So what are the sort of things that will obviously move soil? I mean, we're all aware of those. It'll be machinery. Wind and water can move soil around. So really, it's looking at what practices can we put in place to actually minimise that movement. So washdown stations, washing, scrubbing boots, boot covers. Making sure that people that are visiting multiple farms perhaps don't drive onto fields, park on the hard roadways rather than going into the fields themselves. Those sorts of things to actually minimise movement of soil from one field into another field. Similarly, even on a single farm, if you've got a field that's known to have a higher level of inoculum and one that's maybe moving into clean or virgin soil, then consider about your even internally your own vehicular movement. So you go from clean to infested rather than the other way around, just to try and protect or reduce the contamination of cleaner field sites. How can we reduce the pressure from the soil inoculum? That graph up there shows, the greater the inoculum detected in the soil, the greater the risk of powdery scab disease. Well, rotation helps. It won't eliminate things, but the longer the rotation, the greater the decline in the inoculum level in the soil. So with time, it does decline, and as I mentioned before, if it's a more biologically active soil, it might decline even more rapidly than in a poorer soil. But certainly a standard rotation won't be sufficient to control the disease if you've got a high inoculum level. But rotation is important. Short rotations are bad. Similarly, volunteer potatoes will certainly maintain the inoculum. I mean, they essentially shorten your rotation. So if you've got a bad volunteer problem, that's 1 year out of your rotation in terms of absence of potatoes, and so really you've removed 1 year worth of decline in pathogen inoculum. Again, ensure your soils are good and healthy and well structured, and have a greater chance of actually using the good bugs to start to work on those resting structures in the soil. There's certainly suggestions about using, perhaps more overseas, using of fumigants and locally on biofumigants. Data from overseas has suggested fumigants may have limited application for controlling powdery scab. It's a very tough bug. It's easy to kill the good guys and harder to kill the bad guys. So some of those chemical fumigants may well struggle to actually give you good powdery scab control at all. Biofumigants, the fumigation process again may struggle, but of course you're also adding a significant amount of organic matter into the system too, and that will actually boost biological activity and can have benefits both as a green manure application and as a potential biofumigant. As Shakira mentioned, we are looking at future options. So we're looking at ways that we can maybe target some of that soil-borne inoculum, and maybe we can accelerate its decay within the rotation. Now it's still too early for growers to get excited at this stage, but we certainly hope over the next few years to actually have some products that could be applied during the rotation that will accelerate the decline of the resting spores. Those resting spores are super tough, and really what we're trying to do there is wake them up, and once they're woken up, they release these rather fragile zoospores, and they easy to kill. So if we can encourage more of them to wake up rather than remain in that dormant phase, we have a much greater chance of actually reducing what's in the soil. When we're planting potatoes, what can we do to minimize infection? Obviously, we want to reduce the amount of powdery scab infection into our potatoes. Again, there might be more resistant varieties, more or less resistant varieties. Now, it also depends on which sector of the industry you're in. There may be limited varietal choice, but certainly there are some commercial varieties that have greater resistance than others. There's nothing that's immune, so everything is susceptible to some level, but it does vary. Again, getting good soil structure, getting good drainage, trying to reduce that excessive moisture. In crop treatments, we in Australia, we have one fungicide that's registered for powdery scab control. Again, that needs to be applied carefully. It needs to be applied with sufficient volume of water to actually get it to move through the soil profile to be efficacious. There are other materials that again, we've been looking at, others are starting to use biostimulants and other things that actually help to suppress powdery scab. There is no material available currently that will fully control it, however. Chatting to some people in the States, their way of approaching it is irrigation management. And this is more about tuber disease, where they are essentially limiting water during tuber elongation phase. You get reduced yields, you get defects. I mean, personally don't think that's the way to go, but it will reduce your powdery scab disease. It won't necessarily reduce your root infection, however, which occurs earlier in the season. So from a mop-top virus perspective, that can be difficult. So hence the question marks as to soil moisture management is critical for this disease, but really soil moisture management is critical for potato growing. And again, there are potential future options looking at other in-crop treatments, biological treatments, and organic amendments that can once again help prevent or minimise infection. That's research is currently underway in that area. And that is me. Thank you very much.
Thank you, Callum. Thank you to all our speakers for your insightful presentations. We're going to move over to Q&A. We're close to 5 o'clock, but we're going to keep going, and I'll focus on some of those questions in the Q&A area that have not been addressed by the presenters already. If you have any questions that haven't been asked already, please submit and I will moderate those. So we've had a few responses to some of the questions already, so I'll move on to those that we haven't. This one's for Ian from Nick Seckham. Nick is wondering how quickly New Zealand moved through those phases from eradication to containment and then management.
Approximately 2 years. The survey basically took 12 months to complete. So moving from first detection to eradication was very quick. I think other speakers have indicated that it's almost impossible to eradicate it once it's in the Spongospora and in the soil. Containment, we had to do the survey, which was about 12 months, and we then moved into a long-term management plan. So our response in total was probably about 2 years.
Thank you, Ian. The next question is it known where the seed from the original detection site and the southern trial plot originated from? Will there be any transparency around that? I think this one might be a bit tricky to answer at this stage, given we're in the middle of a response. So, Susanna, do you want to speak to that, please?
Yeah, no, I'm happy to speak to that. In essence, we do tracing, trace forward, trace back to understand where seeds gone to, or potatoes have gone to, or any sort of carrier has gone to, and also inputs that have come onto. So trace forward and trace back, that's fundamental to the response activities. As far as releasing individual properties, it is not Biosecurity Tasmania's processes to identify specific sites. And that's for the health, the well-being of those that are impacted through no fault of their own in this response, so in this incident. So we don't release that information. Thanks.
Thanks, Susanna. Next question's from Nick Saunders. Nick asks, symptoms not seen in first generation, is this just in tops or tubers also? Ian or Nigel, maybe?
In the tops, I think you can see the symptoms in the tuber in the first year. It's the foliar symptoms that you don't see in the first year, is my understanding.
Yeah, I agree.
Okay, thank you. From the chat, we had a question, are there any management implications for having potato mop-top virus detected in crop in New Zealand, for Ian?
It's surprising how disease incursion can suddenly spur on-farm biosecurity. The biggest response, I guess, was on-farm. A lot of growers picked up on biosecurity plans and improved their on-farm biosecurity. Unfortunately, that tends to fade over time, which is a shame, because, as already mentioned by the other speakers, it is a major source of spreading the virus. To date, we haven't included it in our seed scheme. That's something that we might consider in the future if we're starting to see it take off a little bit more. We do know that it is in some seed lines because during the survey we detected it. Currently, it's not part of our seed scheme, so we haven't really changed our management practices significantly, and probably won't until such time as we see a greater impact of the virus on our industry.
Yeah, I've seen a lot of those biosecurity practices have been popping up in each of your presentations, and I think it's just such an important message, especially during National Biosecurity Week. I know down in Tasmania, Taylor from VegNet has been putting out some excellent tips on how you can easily implement practices, but it's not only potato mop-top virus that it's going to protect you from, it's just a smart investment for your business. Next question is also for Ian. Any impacts on international market access?
We don't actually export a great deal of potatoes. Most of our exports are to the Pacific Islands, and really it's had no impact on export markets at this stage, no.
So, Shakira, I'll add to that. So a lot of our trading partners for Australia do have it as a regulation, and that's why they have tight tolerances on powdery scab. So that's why we did a lot of the work we had done in preparation as well. So we do know that some of the markets are looking at mop-top as a defect or a quarantine restriction.
Can I just add that many of the detections that we've seen in New Zealand aren't from tubers where there are visual symptoms of powdery scab. So the fact that there are no powdery scab lesions on the tuber isn't necessarily an indication as to whether it's infected with mop-top or not.
Can I ask a question of Ian, just following that up as well? Then, from your point of view in New Zealand, what was the load of seed potato? So you may have a tuber that doesn't have mop-top, but the outside inoculum. Is there any comment you had about did growers do any dipping or treating of seed surfaces?
They do. Maybe not the best practice in the world, but they do seed dipping in formalin, some of them, when they see high levels of powdery scab. And I guess that probably increased around our incursion of mop-top. They didn't really change their practices all that much, to be honest.
Okay, I think there's also a question here from Peter Cross, similar. Seed cutting, is that considered a major mechanism for spread of the virus? Was there much of a focus on that practice in industry in New Zealand?
we've never studied the transmission of mop-top through seed cutters. The one thing that we did engage with the seed cutters is to try and determine the symptoms or the prevalence of it. Obviously, when you cut the seed, you can see the internal symptoms. So we were trying to get them to report as much of that to us as possible. But to be honest, I don't have any information on how mop-top transmits across the seed cutter. I don't know if any of the other speakers can.
From discussions had in the US, it's a very poor transmitter of a virus, so it's not likely to spread by seed cutting. Yeah, that's the advice I've had from the US.
Thanks, Nigel. Any comments from you, Callum? Any?
Well, again, obviously we haven't had direct experience with playing with it, but that's correct. It's not. There are other potato viruses that are designed to spread by contact and are more of a risk through things like plant-to-plant contact and seed cutting. This is because of that erratic distribution as well. It's less likely and possibly very poorly, if ever, transmitted in that process.
Thanks. Moving on, another one for Susanna. What type of support does the Tasmanian government provide to growers if they do test positive for potato mop-top virus?
Yeah, no, thanks, Shakira, and thanks, Audrey. So I'm not sure whether I've understood the question right, but if the question relates to being able to provide or obtain testing through the plant diagnostic services, then in the first instance, I would suggest that they reach out to the plant diagnostic services, or alternatively, Doug could probably also reach out to Tas Seed to talk about testing too. If the question is around support for if it comes up positive, we're quite in the early stages of this. We can take that one on notice and look to see what information we can provide in due course.
Susanna, there's quite a few. Oh, sorry. Yes, Doug?
Yeah, just to add on to that. So, I mean, we have a number of growers, not a number, a handful of growers that grow outside of the certified seed scheme as such. And they've requested that, yeah, we test their tubers, of which we do, and that's a fee for service. So it just gives them greater confidence around what they're planting and, yeah, work with that.
Susanna, there's a few more questions here that we might address now. So there's a few questions around the detections. Are they in commercial seed and or trial varieties? And another on, you said you think that potato mop-top virus has been in Tasmania for at least 2 years, and what's your reason for this thinking?
Yeah, so thanks for that. Just going to the 2-year thing. So that's based on when we look at those infected sites and we pull apart and try to understand what's come on, what planting material, etc., has been utilised. So we're trying to get a fuller picture of, over a period of time, what has come on, what has gone off, and also how they relate to each other. That information at this point in time suggests to us that it might have been present for at least 2 years. Oh, and sorry, the other question around detection. So as noted right at the beginning of this webinar, so we've had a detection in 2 seed lines, and then we've also had a number of varieties that have shown a susceptibility to the mop-top virus.
Okay, I think we've got a couple of other questions there, but I think what I'll do is I will circulate those questions and get some answers developed that we will then circulate to the registered attendees, and we'll also mail that out along with the link to the recording. So as we wrap up, I want to thank all of our speakers, Susanna, Doug, Ian, Nigel and Callum. Thank you so much for your contribution, for your time and effort to contribute to this webinar today. I'm thinking, the key takeaways for me, very important to see the messaging around robust biosecurity practices, and the importance of vector management, powdery scab management, and the value of industry-wide collaboration. I think that's really important. But as the Tasmanian government and others proceed through the response, we'll look to keep people informed through our communication channels as well. And thank you to everybody that attended and participated and asked your questions. Appreciate your time and commitment, especially on a Friday afternoon. And we'll, as I said, make this webinar recording available to you early next week. Thank you very much, everyone. Have a great weekend.